Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, well, we're back with another episode of PC Archeology. I've been on a bit of a Motorola 68K kick lately with the Agva CompuGraphics series and then the Plexus P20 follow-up. Well, we're back in x86 territory with this computer. This is a Sperry 3070-02, and almost certainly this is a regular PC in here. But the brand name Sperry might not be something you're too familiar with. So in today's video, we're going to do the usual PC archaeology thing where we take a deep dive into this computer, see what it's all about, see if I can get it working, and then also do a little bit of research into the Sperry brand and then potentially who actually manufactures this computer. Because I'm pretty sure this is not made by Sperry. This was actually a rebrand of a different computer. So without further ado, let's get right to it. So looking at the front of the machine, we're definitely getting those beige PC vibes, which I kind of love. Front left of the computer, we have the Sperry logo on a badge, and then we have the keyboard jack. On the right side, we have a 5¼ floppy drive and an empty bay. There's a power switch and the word power with what looks like plastic where a light will shine through. Floppy drive is an interesting mechanism that I have never seen before personally. If you push right here, it raises the disc clamp, so you could obviously put the 5¼ disc in there, and then you just lower this down to clamp it. It's actually kind of a nice feeling mechanism. It's very easy to put up and put down, although I don't love how when you push the eject button or the open button, it kind of clanks up to the top. This machine's probably had a bit of a hard life, or at least it had a hard life after it was taken out of service because it's quite scuffed up and scratched up and, well, I guess all things considered, it's in decent shape. The front bezel is plastic, but the rest of the computer is typical metal. Without having opened this thing up yet, I don't know if this is a 16-bit machine or it's just an XT class machine, but I'm kind of assuming that we're going to be looking at an XT class machine here. The back of the machine is nothing too unusual for PC clones. Our power supply is obviously a non-standard unit compared to IBM's design. It does have a regular US style plug on there as a pass-through. It does say auxiliary power to monochrome or color display. Can support up to 1 amp. Regular IEC mains input. Remember, the power switch was on the front of the case. Our Sperry badge has the system unit number, 120 volts, 60 hertz, 4 amps total. There's a serial number of 25,299. Do you think really 25,000 of these computers were made? It's possible, but I also don't believe it. It probably started at a number like 10,000 or something like that. Sperry Corporation, made in Japan, and there's an FCC ID. I think that will definitely give people clues as to who makes this. But I think if you're watching this video and you've seen enough of my episodes, you probably have a feeling for who made this already, because I've had a similar machine to this on the channel before. Below the badge, we have what looks like a parallel port. We have a set of dip switches externally accessible. And then we have 6 expansion slots, and then we have this additional slot here. But what sticks through is what looks like a 37-pin D-sub connector, which would be for an external floppy drive. We've got 2 coax jacks, probably for some kind of networking, another parallel port, and the video output. And that card is wobbling around, so it's obviously not screwed in. Probably a monochrome card. This card has some words written on the slot cover. It says 10 megabits per second signaling device. So I don't know if that's regular Ethernet or not. The computer itself is very hefty, very sturdy, and very well built. Let's see if we can see anything on the bottom of the machine. Nope, nothing specific on here other than the fact it's 4 feet still. Those haven't been knocked off. A little bit of corrosion and yeah, otherwise no stickers or identifying information. Before we open this up and look inside, let me go over to the bench and let's do a little bit of research to see if we can figure out a little bit more about the Sperry Corporation that is badging this computer, but also who might have actually made this computer and were there any other versions of this computer out there? Let's start off with Wikipedia looking at Sperry. So this company was an electronics and equipment corporation in the US that seemed to have gone bankrupt in 1986 following a prolonged hostile takeover bid by Burroughs Corporation, another office supply company that made computers, electronics, and other office equipment. Sperry had a long history. It goes back to 1910. I guess it was named after the founder, Elmer Ambrose Sperry. In 1955, Sperry changed his name to Sperry Rand because they acquired Remington Rand. And Remington Rand, as you may know, they developed the UNIVAC computer, which was an extremely successful line of computers for businesses to use, big mainframe type things. Of course, Remington Rand was also well known for making typewriters, and looks like Sperry actually had a branded Sperry Remington typewriter at some point. Now, this article doesn't really talk about the details of Sperry's electronics business. I mean, they made the Univac for all those years, but clearly, well, this is a computer branded Sperry, and I have a feeling the date on this is probably going to be before or thereabouts. And it sounds like when the takeover happened, it was the end of Sperry, and most of it just kind of got sold off for parts to other companies, which is very common for these types of companies. They get bought and they get scrapped, and just the pieces that people want will buy them up, and then that's it for the brand. So even though Sperry in 1977 bought this Varian data machines company, so it had mini computers, and we had the large Univac division as well, they obviously at the very end tried to get into the smaller desktop computers. And that was probably happening because they could see the writing on the wall that mini computers and mainframes and stuff were kind of go by the wayside, and well, everyone was going to have a regular computer on their desk. Now, it's my hypothesis that at the end, before Sperry got taken over by Burroughs, they didn't have the capital to invest into making their own desktop computer or IBM PC compatible line. So they almost certainly reached out to manufacturers that made PC clones and just contracted with them so they could rebrand the machines with their logo. Now, from doing reading in the past, because I've had another machine on the channel on a PC Archeology episode that was also a branded Sperry machine. The one I had was not branded Sperry, but I found out later that that particular computer, which I'll show you in a second, was sold as a Sperry as well, or at least marketed as a Sperry, just like this computer was. Well, from research I had done in the past and some talking to individuals, it seemed that Sperry never actually sold any of their equipment to companies. They always leased it. And that same operational methodology extended to these desktop computers as well. And that's probably one of the reasons why there aren't a ton of them left, because they probably all got brought back and reclaimed as assets back to Sperry when that hostile takeover happened, and then most of them just got shredded or destroyed, or who knows what happened. You'd have to imagine that some of them were left behind in companies because of course when Sperry went belly up, the companies were left with these computers, but because these were company assets and not personal computers, they were probably also just sort of thrown away or shredded or maybe given to employees. So you have to wonder how I ended up with this. I don't really know. This was given to me by someone, and it could have been that at some point when this machine was used in an office and Sperry went away, this was given to an employee, they took it home, and it was just stashed away in garage, attic, basement, whatever, and then it ended up with me. Now, when it comes to the relation of this Sperry computer to another machine that I've shown on the channel, it's this machine here, the Leading Edge MP2400L. And on the video on this Leading Edge machine, I ended up having like 2.5 of these computers, and I turned it into one good computer. But the really interesting thing about this Leading Edge computer that we see here is it wasn't made by Leading Edge, because Leading Edge didn't make anything. They always just bought something and rebranded it. This was actually made by Mitsubishi. And the inklings of the fact that this was a Japanese-made computer, at least on the Leading Edge, was, of course, made in Japan, just like this one we just looked at from Sperry. Beyond that, inside the Leading Edge computer, you open it up and it's like all these Mitsubishi cards in there. So that really tells us that for sure, the Leading Edge was made by Mitsubishi. So the connection of that Leading Edge 2400 computer and Sperry brings us to this post on the VCF forums. And if we scroll down here, you notice the photo that user Bolex posted. This is, without a doubt, the same exact computer as the Leading Edge MP2400L. And just so you can see that they are literally identical except for the Leading Edge sticker that's on there, there's the machine that I worked on in the video, there's the Sperry computer. Oddly enough, they have the Sperry logo up at the top of that square sticker, which is odd. They could have centered it a little bit, but they didn't even bother. Original poster Bolex pointed out that on the Sperry, the motherboard was made by Mitsubishi. So 100% the Sperry machine and that Leading Edge machine are identical. And that really makes me think that almost certainly Sperry, when they contracted with Mitsubishi to sell this 286 machine, they probably did the same thing with this computer that we have on the bench today. And it's an XT class machine because it's smaller and far less big than the 286, built by Mitsubishi and potentially also co-branded by Leading Edge. Mitsubishi, being the original equipment manufacturer for these computers, might have had an exclusive agreement with Sperry to market this computer, or at least the 286 one, exclusively for Sperry, at least for a certain time. But obviously, it was not totally exclusive because their Leading Edge version exists of the 286. And it makes me kind of think that potentially this machine, if this follows the same history and lineage as the 286 one, maybe there's actually a Leading Edge version of it as well. So doing a search for the model number of the Sperry does bring up a VCF forum post of someone else who actually found one of these machines as well. a Sperry branded monitor, and what would have been the hard drive that was probably in this computer that was taken out. And this post is from 2018, and the original person who posted this is looking for additional information on switches and documentation and whatnot about this computer. Before we scroll down, because it looks like there's more posts, why don't I do a quick search for leading edge Mitsubishi XT, and let's see if that turns up anything. Ah, yes, it absolutely did. So this is the extremely rare 1982 leading edge MP1673L, known as the Model M because they used Mitsubishi parts. That is this computer with a nice silvery gray paint on it. That's pretty nice. Is that the same weird floppy drive as well? I think it might be. Look at the red LED for the power light. That's kind of slick looking. I can see the keyboard cable, by the way, is disintegrating there. And here's another shot with the computer paired with an IBM 5153 CGA monitor. And yeah, it's looking pretty nice. Now scrolling down a little bit, Bill has a picture of the other leading edge model, the Model D. And I've shown this on the channel multiple times, actually. I think I've done 2 or 3 PC Archeology episodes with this computer. The D in Model D signifies this was a Daewoo sourced computer. And it's also evidence when you open it up and you look inside it, you can see that it's made in Korea A, but then it has Daewoo printed on the motherboard, if I recall. This one is the much more common leading edge, at least here in North America. The Mitsubishi variant of the leading edge is not something I've ever run into, hence Bill saying that this is extremely rare. I don't know how true that is, but that's definitely a machine that I've never personally seen, while these leading edge D models are pretty common, and like I've had a few, but I've known lots of people who also had these when they were growing up. Anyhow, that pretty much confirms that this is going to be an XT class machine. It was branded by Leading Edge as well as Sperry. I don't know if it was sold as Mitsubishi in other places in the world, but here in North America, probably just those two. The Leading Edge variant is pretty rare, but I think this Sperry version is probably even more rare. Although, funny, I was able to find pictures of both of them online, so maybe they're not that rare. If you personally have ever seen or run into the Leading Edge M variant or this machine in the wild, I'd love to hear about it in the comments section. All right, we're going to try something new with a top-down camera view over on this area of the bench. And I can do this, of course, because the plexus is not sitting here on the bench taking up space. With the fasteners out, my assumption is this slides forwards, and it does. How does this come off exactly? It's always a learning experience when you start with a new computer. Okay, well, on first glance, let's start popping these cards out. 3Com 8-bit network card. This is a NW1000. Next up, looks like we have an 8-bit RAM card. It says at the bottom here, Memo 576. So this is probably not original. Dip switches to set the starting address and a serial number of 8233. These chips are 256 kilobits times 1, so 512K on here. Odd there's an extra bank. Next up is the video card, which was loose, and I thought this was a monochrome card, but this looks actually, well, you know what? No, this is going to be EGA, I'm pretty sure. I'll just zoom up a little bit so you can see it a bit better. This chip here, GN002001-A, and the next line, TC17G042AT. The card is curious to me. I thought, like I said, EGA, but that doesn't make sense because EGAs don't use 6845s. CGA and MDA. But what's this giant chip? Oh, it says Genoa Systems, and I just noticed that there are dip switches there. It just doesn't have the usual EGA things like the 2 RCA jacks, and it has a parallel port, so it's just a bit unusual. But yeah, Genoa Systems, oh, right there, Spectrum, model 4600N. We have 128K of RAM as well, so these are 4464, so 2 of these is 64K, so for a total of 128K. So that definitely means this is going to be EGA or something like that. It's just, yeah, like I said, odd that it's got a 6845. Maybe this has really good CGA compatibility with the 6845. Just typically you don't see those on EGA cards. Next up, we have another Ethernet card, the one that said 2RCH on the back. It says 1993 Artisoft Incorporated. I don't know if these cards were originally in this computer or they were just stuck in here for storage. Don't know much about this, but it does say made in USA and Artisoft. So this is probably, I wouldn't be surprised if it was like an NE2000 type card. It's also 16-bit. So that's what makes me think this is probably just stored in here. And our last card is our floppy controller. And would you look at that? Mitsubishi logo right there. Now, we already kind of knew that this was a Mitsubishi computer, right? Because, of course, we saw the leading edge and it had that M for Mitsubishi versus the D for Daewoo. But this is a very standard style floppy disk controller. Slightly unusual. I think this actually has a ROM on it And this has dip switches, so this probably allows high density support. It does say on high, off normal. So maybe you switch those and this will run in high density mode and you need the ROM to support that on XT class machines. It's got an NEC 765AC floppy drive controller chip. Okay, well, looking down into our system, this does say system board made in Japan. There it says Mitsubishi Electric Corp. There's a bunch of bodge wires right there, a few delay lines, moving the floppy cable out of the way. There's other cool stuff happening on here. So what is this? So that's the math coprocessor socket. Hopefully you can see that. It's got like a cover on it or something. Don't know what's up with that. But we have a normal 8088-2, so that's the high-speed variant, if I recall. Yeah, I'm pretty sure that is, so it could run up to like 10 megahertz or so. The motherboard definitely has some curiosities. There's a 40-pin connection right here, so this thing must support XT IDE, which is not the same as those 8-bit cards we use these days. This would be an IDE interface that's designed for 8-bit systems. 2 BIOS ROMs. There's a clock battery on here, which does not appear to have leaked. I need to get that off immediately though, because it's NiCad. Definitely has a lot of tantalum caps, so we could have a short circuit. Nothing looks out of place or damaged here, which is good. Without a doubt, the spacing on these slots is wider than standard IBM PCs. I'm looking for date codes on ICs, and this one here, this LS240, has 1984 49th week. Which, sort of looking around, that appears to be the latest date code I see. I don't see any 85 date code. So that tells us that this motherboard, at least, was put together in 1984. Take a look at the power connectors on the motherboard as well, completely non-standard. In fact, it's really funny because looking at these connectors, if you ever worked inside televisions, these are very much like the connectors used in TVs. Like I've seen deflection yokes that use connectors just like this. And of course, Mitsubishi was a giant manufacturer of everything. And at that time, when this machine was made, they did make TVs and tankers. Something else, this floppy drive is also made by Mitsubishi. So this whole computer probably was made by Mitsubishi, every part of it, including the power supply. There we go, made by Mitsubishi Electric, the power supply PC04-UB. So this whole computer made by Mitsubishi, and then of course sold and marketed, or leased at least, by Sperry and Leading Edge. Let's get this battery out of here. It is some type of miracle that this battery has not leaked. We'll see a little bit more in a second if it has. I'm just gonna metal fatigue it right out of here. Maybe one of the reasons why it hasn't leaked is it's not a Varta battery. It's Yuasa brand. It's a Japanese brand. And I found these batteries to always be really high quality, but you can see no leakage whatsoever for a computer from 1985. That is frankly amazing. If only other manufacturers use these instead of Vartas. Now looking at this machine on the inside here, this thing is clean. So it's a little bit of dust on here, but that's it. It looks fantastic for its age. And while we're in here, I just wanted to document the switch settings. There are dip switches on the back, which I need to document, but there are these ones on the inside as well. Let me just write down the way those are set. Plus we have some jumpers there, and I'll look around for any other jumpers. That way, if you have one of these machines and you want to try to configure it in a way that maybe works, if someone's messed with those, maybe you could use this machine as a starting point. Okay, I've documented all the switches. I will type this stuff out and it will be in the description most likely, or maybe I'll put a link to my GitHub or maybe archive.org where I'll upload this information along with the dumps of the EEPROMs. There are 2 EEPROMs on this board. One is a 27128, so that's 16 kilobytes, and the other one is a 2732. That's quite large for an XT. Typically XT clone type machines and the original 5150 had an 8K EEPROM, that was it, especially if you're not including BASIC. So I'm not sure what this thing is doing with 20K of EEPROM. That just seems like quite a lot, unless it's got a special ROM maybe for the hard drive, which is quite possible. This XT IDE might need an extra ROM, which could be one of these. It's just a bit more ROM than I would have expected on an XT class machine like this. Incidentally, the clock calendar setup that's in the bottom corner just has a standard Oki 58321 chip. Those are pretty common clock calendar chips, and there's the little 32 kilohertz crystal right there that runs this whole thing. Okay, well, I don't think there's really too much for me to do other than unplug the connectors from the motherboard, from the power supply, and I'm gonna get the load tester And we'll see if this power supply can supply a nice stable 5 and 12 volts. I made a recent video on the second channel where I kind of explain how I do that load testing. And incidentally, I see a 5 volt adjust potentiometer right there. That's a nice little feature, Mitsubishi. Thank you for that. Programmable DC load is plugged into both the 5 volt rail and the 12 volt rail through this Molex connector, and I have it set to draw 20 watts on each. I might lower it down to 10 watts on channel 2, which is the 12 volt rail. Channel 1 is the 5 volt rail, and that needs to supply a little bit more power because, you know, all the TTL logic that's on these actually draws more current than 12 volts usually does. So both of the channels are already activated, and we are on CP mode, which is constant power. That just means it's set to draw 20 watts no matter what the actual voltage is. So I'm just going to plug the mains input into the power supply, which should be turned off right now. Oh, it's not. It is running. And we have a problem immediately. Voltage dropped down to less than a volt. I mean, it's less than 0.0 volts, but it's drawing 1.3 amps. So is it possible the 12 volt rail is that weak that it can't even supply even just 10 watts? Let's lower it down to something like 5 watts and see what happens. Generally with a power supply like this, you need to load up the 5 volt rail, and 12 volt rail doesn't really matter. In fact, we could just turn off the second channel altogether. And you can see it is supplying 12 volts without any issue. Although, oh, actually, the 5 volt rail is down at 3.55 volts. So that's not great. Reducing it down to 10 watts, and we're still at 3.8 volts. Well, that's something is clearly wrong here. If we lower it to 9 watts, 8, 7, 6 watts, we're at 4.8 volts. 5 watts, and we are now at 5 volts. So that's obviously not going to run this motherboard. If we plug this into the motherboard, that is going to fail. Odd is the fan is running at full speed all the time, and I'm wondering if that's a 120 volt fan, because obviously the 12 volt rail was almost down around nothing. Here, let's turn it on. Okay, so it's able to supply 5 watts, while the 5 volt rail is still at 5 volts. Let's slowly ramp up the power again. Okay, oh, wait a second. Suddenly it's better. So it's like this power supply wasn't supplying 5 volts because the 12 volt rail wasn't loaded at all. Because we are at 15 watts now, 4.9 volts, and there's going to be voltage drop across these connections that I have here. So let's go all the way back up to 20 watts. And we're at 4.88 volts. Now I have a feeling that's a voltage drop across this Molex connector and stuff, because I am drawing quite a bit of current just through these little thin wires. And remember, by the way, that everything is unplugged from the computer. So the power supply is only plugged into the electronic load. So if anything goes wrong and these voltages are way too high, it's not going to damage anything on this computer. All right, so I'm going to connect up the multimeter to the other Molex connector just so we can see what the voltage is without the voltage drop. And yeah, there we go. We can see we're at 5.058 without the voltage drop of this cable. And on the 12 volt rail, we are at 12.1 volts as well. So let's turn the power supply off and on. I'm using the switch on the front because I want to see what happens exactly. Oh, it comes back. It's okay. So the funny thing is, it really felt like with the 12 volt rail loaded up, I had it at, what, 20 watts? That was just too much, and the whole power supply kind of went into some weird mode where it was barely supplying any kind of voltage. Let's turn up the draw. I mean, we're at 16 watts on 12 volts, and still everything looks fine. Regulation is happening perfectly. And there we are at 20 watts on both channels. 12 volt rail directly off the Molex connector, still at 12.097. And let's check the 5 volt rail again. 5.06 volts. It's regulating perfectly. What was going on earlier? I'm going to turn this off and turn it on again and see if we have the same problem. No. Yes. Okay. Interesting. 5 volt rail is still fine, but this 12 volt rail does not work properly with that kind of a load. And the funny thing is, did you see what happened there? Okay, let me power this off and let me demonstrate what happens. Okay, so with an excessive load on the 12 volt rail, which is, well, about 1.5 amps or so, 5 volt rail is totally fine, but 12 volt rail is just not working. It's less than 1 volt. If we turn off the 12 volt rail, so there's no load, 5 volt drops to 3.8 volts, and obviously 12 volt jumped up to 12 volts, and we turned it on again, so we're back at 20 watts on 12 volt rail, and now we're fine. Both rails are regulating perfectly. This power supply has a weird quirk, I guess you could call it, where if the 12 volt rail is immediately loaded up and it goes into some kind of protection mode, and you see we're drawing 1.6 amps right now, which is more than we were drawing when it was in this weird fault mode, and then the 5 volt rail is completely fine. So if we change back to our 12 volt rail, let's crank up the power. How high can we go? Okay, 70 watts. That was too much for it. Sorry, power supply. So we'll reset it there. So it's 40 watts is totally fine on the 12 volt rail. That's 3.3 amps. 50 watts is fine. Oh, 60 watts is fine. Okay, this power supply is weird, but it seems to be working totally fine. I'm gonna lower this back down to just 10 watts there. This is a reasonable amount of load. If you had, say, a hard drive plugged into this thing, it's not gonna start drawing its current immediately. It usually takes a split second, and then the spindle starts to spin, and that's gonna draw the 12 volt rail down. So therefore, I think what's happening here is probably fine. So I think what I'm gonna do, I'm just gonna let this thing run just like this. I don't really need the multimeter hooked up because obviously we can read the voltages on here. I'm just gonna let this sit here and draw 30 watts off this power supply. I'm gonna leave it for like about 10 minutes or so, just to ensure that nothing bad happens, nothing catastrophic happens in here. But it really, other than the weird quirks of this power supply, does seem to be working without issue. And in fact, while I wait before we do this length testing, how much load is enough load on the 12 volt rail to actually start it? I'm gonna start it at 1 watt. Oh, already the 5 volt rail is dropping 2 watts. 2 watts seems like about the minimum. So if we turn this off, turn it back on, yep, everything comes back with 2 watts. But look, if we turn off channel 2, obviously 5 volt rail goes away, turn off the computer, turn it on, goes away immediately. And if we change this down to 1 watt and turn on the second channel, it's at 4.7 volts, so it's a bit low. So it seems that 2 watts on the 12 volt rail is the minimum for this power supply to regulate the 5 volt rail properly, which is odd. I'd say this is a strange design. I'm just not used to seeing that. I'm gonna turn this up a little bit, but that had no effect on the voltage. Once you went over 2 watts, that has no effect on the voltage on the 5 volt rail, other than the fact we know that if we draw too much on the 12 volt rail, then the power supply, well, it will start and the 5 volt works, but the 12 volt rail does not regulate properly once you're over about 1.5 amps. Okay, well, it's been running for about 10 minutes, 0 issues. So I'm gonna shut the power off, give this thing a break. Now, one thing is, I was sort of thinking about what it would take to power this thing up. You need a resistor of maybe 75 ohms across the 12 volt rail to give that 2 watts of load. Problem is, I looked through my power resistors because it has to be something that can sustain that. So it's gonna get pretty warm. I don't have any power resistors at that correct ohm rating. So I guess I'm just gonna use my electronic load to do this. So I'm just gonna set this down to 2 watts and I'll just leave this plugged into one of the Molex connectors and we'll test with that. Now, while this thing was doing its little stress test, I used the multimeter to check that there were no shorts on the 5 volt or 12 volt rail on the power supply because of shorted tantalums. There weren't. I also checked to see if there were any shorts on this floppy drive controller, and there weren't. And I also checked to see if there were any shorts on the floppy drive itself, and there also were not. So I think we're good to give this thing its first power up off the power supply, and we'll just try it first this way without the actual floppy controller. Oh, incidentally, I popped off the little cover here that was on the floating point unit, and yeah, that's just an empty socket there. So I don't know why they did this, other than trying to prevent people from accidentally putting the CPU in the FPU socket. I mean, it's clearly labeled on the board, which is 8088 and 8087, so I don't get that. Okay, so the speaker is hooked up, so if this thing comes to life, we'll hear a beep out of it. This is set to 2 watts and is turned on and it is connected. Floppy drive is connected to the power cable, as is the motherboard. Let's see what happens. And the good thing is, by the way, is I know you can't see it on the camera right now, but I can see the voltages of both rails on this, just in case they aren't working properly when I turn this on. So here we go, 3, 2, 1. Oh, okay, so weirdly enough, 5 volt rail came up without a problem, but the 12 volt rail did not. So I'm gonna turn off the load and let's see what this does now. Okay, now we're at 12 volts and 5 volts. So the floppy drive connected and the motherboard connected seems to be enough to load up the power supply properly. That was loud. And check this out. That is so cool, a flashing power LED. So I guess it's telling us about some kind of error code, and that's not something that you ever normally see on these things. Generally, the power LED is just hooked directly up to the 5-volt rail, and it's not something that could actually be controlled by software. So let's power this off again and power back on. So it comes on solid, and the voltage rails look fine on the load, and the load is turned off, like I said. We got our post error, or whatever that means, and that's flashing. I love that. I freaking love that. Clearly, Mitsubishi, when they designed this thing, they were trying to be a little bit different than IBM and trying to up the game a little bit, make this thing a little bit better than IBM's 5150 and 5160. Okay, the next test is to try this with a video card and the floppy controller connected. Now, the funny thing is, we know that this was sort of used as a storage machine because obviously it had stuff like this random 16-bit ISA card, which could possibly work in an 8-bit slot, but why would you need two 10 megabit Ethernet cards in an old XT class machine? So we don't know for sure if this is configured correctly for, like, say, CGA or MDA or whatever this was used with, and then of course the switches on this computer need to be configured appropriately. So it's quite possible connecting this up might still result in a post error, but at least we have now the parts that are kind of necessary for a working system. And of course, without a monitor plugged in, and I don't have a monitor over here, we'll have to move this over to the bench. Well, I just want to see if this thing gives us the same post beep error code. And the one last thing I do have to connect, because we know we're going to get an error, is let's plug in a keyboard. So I have a Model F here. Pretty sure this is going to use a standard XT style keyboard, so this is going to be fine. I'll just put the cord like that. And here we go. Let's see what happens now. Got the solid power LED. Now we can assume that it's counting up or doing something. Oh, okay, same exact post error. Long beep, single beep. The last thing I need to try is let's pop in this RAM card because it might be configured to look for this much memory and maybe it's unhappy that it's not finding it. So let's try one more time and let's see if that makes a difference at all. I just want to hear a difference in the beep codes. Otherwise, this thing might have a fundamental problem. Oh, this is taking longer. Oh, this is good. It's probably counting up the RAM, and it was counting up the motherboard RAM, and now it's switched to counting up that 8-bit card's RAM as well. And probably the switches on the motherboard are configured in a way that tell it how much total system memory there is, and now maybe we have the correct amount. So I'm expecting to hear like beep beep, like 2 short beeps, maybe to say everything's good, something like that. Wait, 1 beep, no flashing light. I think this thing's working. That is awesome. Let's get this over on the bench so I can plug it into the RGB to HDMI so we can see what kind of video signal this thing is outputting and make sure that, well, it's actually working. It really amazes me when stuff just works. Like, this computer is so old, it's from 1984, and yet who knows when was the last time it was used, and yet it just powers up and works. That's just frankly incredible. It even had a NiCad clock battery and it didn't leak and damage anything. It totally blows my mind. And it's funny in a way because you look at newer machine stuff from the 90s, Amiga 1200s and Macs and stuff like that, none of those work properly, of course, because of all the caps that have damaged them. This thing, on the other hand, no bad caps, it just works. Now, I'm saying it just works without us having actually seen it work, but the thing is we heard the beep codes and that probably means all is good. And I love that flashing power LED. That's very helpful, very unique for this rare computer, and I love that. Okay, I'm gonna grab a cable here, so I'll get the RGB HDMI hooked up. And the reason why I was doing the top down over there is because the bench camera I have, this one that's sitting right here, it doesn't have a very wide angle. Well, and when the camera's mounted this close, I should get another mount for it where I can move it higher up. And then I would actually be able to get the whole computer in the field of view. I should do that actually, because I have a kind of an arm mount. You can kind of see it hanging down back there. I could probably stick it up there and do the same thing with this camera. Anyways, okay, let's get this cable hooked up so we can see what's happening exactly. The questions I really want to answer are, does this floppy controller actually have a BIOS ROM on it? What was I looking at that large chip and thinking it was a ROM? Is that incorrect? And does the motherboard have XT IDE, or what does it do when we turn it on? And then what kind of special features does the motherboard have with all that ROMs? Does it have its own menu? Does it have more information that pops up? Let's just figure that out. We'll just go straight for IBM CGA as the profile on RGB to HDMI. And that's because I know this card can either output MDA or Hercules style video, or it can do CGA or Plantronics, which is also similar, 15 kilohertz. And most likely this is probably used with a color monitor, but we'll find out very shortly. All right, power supply is connected up to power. It's turned on. Here we go, 3, 2, 1. There's that noisy fan. Wow, that is loud. So we're watching for any kind of video output. So far, nothing. And it says no sync detected. This video card could be bad. I might need to swap to a different card. But if this were outputting even an MDA signal, we might not see the actual video, but it would say sync detected. So something's the matter here with this video card, I think. Luckily, we'll just... Okay, we got the good post beep. Oh, the floppy LED's on. I don't think I mentioned that before as well. So it's like trying to access the floppy drive. Okay, I'm going to switch to this video card because I know this one works, and this is CGA or MDA mode, and it does support Plantronics as well. So it's basically equivalent to this Genoa card. Okay, my VTech card is in. Fire this back up. Oh, okay, ignore the flashing. Oh, it initialized. Okay, what oddity. So it waited until it was done with its post-checking to actually initialize the cursor? What's it doing? Control, delete. Okay, so the computer's responding to keyboard pushes, but doesn't print anything on screen. Now I'm thinking, let's turn this off. I'm going to switch this card to MDA mode because it might be configured for a monochrome card, and we'll just need to switch our RGB to HDMI over to that mode. And we'll switch this over to like Hercules. I think that's a relatively close mode for this card, and we'll turn this on now. I'm wondering if, because it's initializing the wrong type of card, or actually thinking about this, maybe it needs a card with a ROM BIOS, because this has a ROM BIOS. So maybe I need to put a VGA card in here. And the BIOS tries to initialize the video card, but what it's doing is it waits till the very end of the post process to actually initialize the CGA or MDA card. It doesn't actually print any text to it because it's a secondary display kind of thing. Oh, okay, I stepped away grabbing this card, and it's lots of beep codes. So it really was unhappy with that CGA card set to MDA mode. All right, let's swap over to VGA and let's see if it can initialize. And this is the VGA card. It's just a 8-bit one that I like to use. Western Digital Paradise type card, very reliable. I have a bunch of these. So this type of troubleshooting, like swapping cards, trying different things, this is all kind of par for the course when you have a machine that's not really known to you, especially this one with a bunch of dip switches that we can't just easily look up. Now, I did do a little research, and I think I found the manual for this machine, which it does explain all the dip switches, which is good because there are a lot of dip switches, and trying them all out, one at a time to try to figure out what each one does. If you don't have the manual, it's okay if you have like 8 switches or 4 switches, but when you have as many as this thing has, which is like 16, okay, does not like the VGA card, obviously. So that's interesting. So it really only likes the Genoa card, and it likes the other VTech card set to CGA mode. Okay, so what have we learned? So VGA not working, MDA not working, but CGA card works in that it finally initializes, you get a flashing cursor, but it's looking weird. And then we have this Genoa card that doesn't seem to do anything, even though the computer doesn't beep and complain about that card being in. So I think our best bet is to stick with the VTech card, stick with it set to CGA, and let's go try to figure out the dip switches because maybe they've been fiddled with and that would prevent this computer from potentially working properly. So back on the Sperry VCF forums thread, I finally started scrolling down and reading through the people's responses. And one person says that the leading edge Model M, which is the computer we looked at earlier, is the same. But the thing is, it's clearly not. Because if we take a look at this, there is Model M MP1676L. It's a 7.16 megahertz XT class machine with 256K of onboard RAM. I never actually looked at how much memory this has on board. The RAM is soldered on this board, by the way. So if it has a RAM fault, that's going to take a little bit of work to fix. It does say it has a 32-bit external memory card slot. No, clearly not. But it also mentions that it has a serial port and a floppy drive interface. And it has P7, P6, and P8. Well, this computer only has one connector. It doesn't have these additional connectors, not to mention CPU and NPU are down here by the RAM, which does not at all what this thing has. And there's a separate keyboard controller, and I would say that this thing does not even have that keyboard controller at all. Not to mention leading edge also has 6 slots according to this diagram, but this machine here in front of us has 7, and the spacing obviously is different. So this motherboard does not seem to be that similar at all. Now, out of curiosity, let's look at what P8, P6, and P7 are. So P8 is an onboard floppy interface. That's that one, 34 pins. P7 is the 32-bit memory card. Okay, well, that's P7. It's over there by the battery. And then P6, which happens to be in the same position as the connector that I thought was the XT IDE, it just says no connection. Now, one thing that is interesting, though, is J8, which is the 25-pin connector on the back of the computer. it lists that as a serial port. Now that 25-pin connector on the Sperry has the same gender as a normal parallel port, which is why I kind of assumed it was a parallel port. But on second thoughts, I think it is actually a serial port even on this, even though the gender is backwards from what you would expect on a PC. And the reason why is down here, we have an 8250. This is a serial UART type chip. You may have recollections in the past of replacing 8250s with 16550s. Those are similar pin-compatible chips as this, but they have a 16-byte FIFO buffer in them, which allows for better multitasking for later operating systems. MS-DOS doesn't really matter necessarily, but certainly 16550s work better in these sockets than the old 8250s, which is what that is. And on this document here, we have these 4 jumpers, which have 2 different positions. And it's very similar to the jumpers that were on this over by that 25-pin connector. And according to what it says here, it says it either changes the serial port between voltage mode and current mode. So current loop mode, I think, is for certain types of terminal, and voltage would be for normal RS-232 operation. Plus a couple jumpers here select whether it's COM1 or 2 and the IRQ. And then there's a little bit of information here on the various switch blocks. And of course, we have switch 1, 2 blocks on the motherboard, and switch 3, I think, is the one that's on the back side, which, yep, matches what it says here. And the switches that are exposed to the back allow you to change the CPU speed and the floating point unit speed, self-test enabled on or off, plus serial port, X on, X off, disabled or not, leading edge advanced features enabled or disabled, monitor type selection, and continuous self-test. The leading edge machine appears to have 256 kilobit RAM chips installed, but the ones that are on here look like 4164. So this looks like it only has 128K of memory, which coincides nicely with our little RAM card here because we know this has 512K, plus the 128K on the motherboard, that gives you 640K total. Now back on the thread on VCF, another user has posted, looks like a photograph of their motherboard from their Sperry, and yes, that's exactly the same as this one, other than it's missing that little cover over the math coprocessor socket. Looks like everything else is configured the same. I'm just checking those jumpers because there are these blocks there and those. And yep, those are configured exactly the same way. And their motherboard also has 64K by 1-bit DRAMs, and it looks like it has parity because there are 9 chips and 2 banks, so 128K of RAM. And for them, when they powered it up, they got time of day error and this postcode ETD10. Interesting. We didn't get anything out of the CGA card on ours. Back on the thread though, if we keep scrolling down, someone mentioned in here that there is the manual for this. Here it is. This user, Bansod, has one of these machines with the original manual, and I think they scanned it and uploaded it to archive.org. How freaking amazing. The Sperry Personal Computer Operating Guide for DOS 2.11. So there's the PC with double floppy drives. And I have scanned through the manual a little bit, and it's actually pretty good. And the reason why is it actually has some pretty comprehensive problem-solving sections that really goes into detail about the switches, which is exactly what we need to do to see what's going on with this video card situation. So first off, it says that all these switches need to be in the off position for normal operation, and it looks like they all are. And the only one I need to check is on the back, switch 3. And switch 3 on the back's on the on position, so that's correct. Next up, the configuration for 640K of RAM, which I think we have with our expansion RAM card, and it looks like it is configured appropriately already. Yep, that totally matches. Next up, we have the display monitor section, and I think this is where we are potentially getting hung up. So we want to have medium resolution, which is CGA, and that's 80 by 25 lines. On and off. On and off. That's exactly how it's configured right now. And then on switch 3, that's the block on the back of the computer, medium resolution for CGA, that should be switched to on the up position or on. All right, and that switch was in the down position, which is high resolution. And I think what that means is it designates that this would be for EGA or VGA, because it's going to be using an external BIOS to initialize the card. And potentially with this Genoa card, maybe that's what's necessary, but it's definitely with this CGA card I have in here now, it should be in the medium resolution setting because the BIOS on the motherboard is actually what configures the card. There's no BIOS on the actual video card. So switch 2 is now in the up position, which might fix our problem with that CGA card. Now, as for the floppy drive configuration, we are currently set to 1 drive. Looking down at the motherboard, on, so that's good. And printers, that doesn't matter. We don't have a printer connection in there right now. CCU, the asynchronous CCU communication control unit, I/O port address can be changed by moving the jumper plug on the system board. Okay, well, those are the 2 jumpers that are down there near the 40-pin connector. And I think that just changes the I/O address for the COM port. Yeah, it looks like you can either have it at 3F8 or 2F8. Now here's what's interesting. It's talking about a fixed disk controller, an 8-bit one, and you can see by the 3 connectors on there, this is definitely an ST506 or MFM style controller, which was not in this machine. And I guess that kind of makes me wonder, like, what is that 40-pin connector that's on the motherboard if it's not the XT IDE? I don't originally know what kind of hard drive was in here and was taken out, but I wonder if it was taken out with the hard drive controller, and that's why we don't have either of those. Is there anything else for us to read? Because that sort of leaves some questions, like what is that 40-pin connector? Why wasn't that even mentioned at all? So now it's talking about the medium resolution color controller. So this is the video card that would have been in this machine. If that's the card right there, that is certainly not the Genoa card. So I guess someone has swapped that out as well. It just tells you how to configure the switches on the motherboard to get that working. And it looks like the original card that came with this thing, yeah, just normal CGA pinout with an RCA jack for composite video. And here it's talking about the printer controller, aka parallel port, so another card that was not installed in this machine. Memory expansion board 3, 256 kilobit memory expansion board. Okay, so wait, this is a card that actually plugs in the motherboard. The motherboard in this picture absolutely matches the leading edge diagram. The CPU is down here with the floating point unit. We have the P7 connector, which it says is for the RAM expansion right there. Look at the RAM expansion board. It mounts to these two posts. And there's a connector there, and there's something else over here. So I suppose we have different versions of this motherboard, even in the Sperry computer. And some of the versions of the Sperry actually match the leading edge, but obviously the one that that user on VCF has and this one don't match. I mean, even more funny is it shows the RAM expansion card installed and the jumper blocks are way up there and they're split apart, and that's just not at all how this motherboard looks. The rest of the manual just goes on to talk about some other cards we don't have. Huge thanks to the person who uploaded this to archive.org. That just warms my heart that people take the time and effort to scan the manuals and upload it, because I know it's time consuming, but it's so invaluable to people like me where we really need the help with those 3 switch blocks on this machine to get this thing working. Well, let's see if this thing actually works now that I flipped that one switch that hopefully allows the CGA card to work. Okay, here we go. Okay, video card just initialized. Maybe? No, it didn't. I haven't got the post beep. Okay, video card initialized. The floppy drive is doing something, but it didn't seek. Of course, the floppy drive could be broken. The positive here is the cursor looks normal. The negative, we're in artifact color decoding mode. That is no problem. We just turn this off here. There we go. That was an RGB to HDMI side effect. Floppy drive 20, timeout error. Could that just mean because it was trying to boot and couldn't find a boot disk? That is quite possible. Let's use my cleaning floppy here to try to clean the heads. Just pop a little bit of 99% IPA on there. Okay, so the disk was spinning there, which I think you could just hear. Control-Delete, I guess. The fact that we're getting an error message means that the video card's being initialized properly. Sorry about the flashing. And definitely I can say that the problem we were having, there we go, the floppy drive is spinning, which is good. It's cleaning the heads, hopefully. Let's turn this thing off. You know what I didn't try is moving the heads. Oh, they do move fine. Okay, so while the power's off, let's just double check that they move without issue. Oh yeah, nice and smooth. This machine's in really nice shape. When I was doing that super fast BIOS stuff, I made these disks for booting. Let's see if we can boot into this. It has the absolutely slowest, ridiculous boot process where it just doesn't initialize the, the video card for a long time. And then it finally does after the RAM check is done, So on a regular video card, you wouldn't get that flashing. That is happening specifically because the VTech card doesn't support the blanking. That way, when you type DIR, you don't get snow, but you also don't get that flashing that you would get on a normal IBM CGA card. Now, as I think I was trying to say, but I got cut off when I got distracted when I tried to boot the disk and didn't work. That switch on the back, that switch 3, which enabled the video card BIOS or not, that is why the CGA card was not working. Now, right off the bat, this computer freaking works. That's awesome. Floppy drive works. I mean, this thing is fully operational, except for this Genoa card, I suppose. It booted right up and relatively quickly as well. Let me pop in the Miss Pac-Man disk. Let's see about it booting Miss Pac-Man booter. I'm sure this is going to work without issue. Oh, there we go. It worked. Nice. F1 to start game. Yes, it's loud. It's not a bad version of the game. It's just a little bit slow. It also supports, I have to yell over the speaker, it supports composite color. And when you're using that, it looks a lot better. But it's very loud on this machine. Other thing that I really hate is if I push the, what is it? Has some weird movement bugs. If you push the up key, like right now I push up, now it didn't do anything. But sometimes when you push up, it moves the Miss Pac-Man character to the right. And I don't really get that. So watch, I push up, and instead of waiting until I got to where I could go up, it starts going the other way. But this has nothing to do with the computer. This is entirely to do, let me reset this thing because it's so loud. There we go. This is entirely to do with this game, but this computer is freaking working, so that is awesome. I think the next thing I should do is let's plug in the XT IDE and see if we can get this thing booted, because I'd like to dump the ROMs and see what we can do with that. Oh, it's working. Nice. What we can do is we can take a look at the clock directory, because this particular clock utility is pretty good at supporting like many different XT clock styles. And let's see if this works. I could type clock T. Testing for AT class computer, testing for integral BIOS support detected. The BIOS just supports the clock. I guess I could try by setting the clock to something. I'm going to power the machine off and then back on, and let's see if the time or the clock was saved at all. One thing I noticed is that there is no floppy drive seek on this computer. So that's kind of nice. It doesn't have the noisy seek sound. I'm not sure that worked, because I think I have something in my auto exec or config sys that will prevent this from booting. And yes, the computer has locked up. Problem is I use this CF card on 286s and 386s and stuff all the time. And occasionally I put stuff in the config sys that doesn't play well with XT class machines. Now, this video is turning out to be kind of chaotic. I haven't even checked to see how fast this computer is. That's probably something I should work on right now. But I suppose the first thing I should do is fix my config sys so this thing actually boots properly. Uh-oh. I tried to run edit. I saw like it for a split second, and now this. What happened? I wonder if this BIOS is not fully PC compatible. That technically is possible. Okay, I'm using VI, which is a lot easier and lighter to use than edit. There was Nancy, NNANSI.sys, which I think doesn't work on XT class machines. Okay, everything should be fine in my auto exec now. I completely forgot to check the date, because I did power cycle the computer and I rebooted it. It is gone. Maybe you need to have the clock utility, 2092. I forgot what date I typed in. I thought I typed in 1992, didn't I? I'm going to put in 1289. Then you got to do clock U to update that time. Now I'm going to power cycle the computer one more time. We're going to do two things. We're going to see if my auto exec can fix this fix this thing so it can boot properly now. And we're going to see if that clock works. Well, 1992 or 89 was the date I put in there. Yep. Okay. Things are looking good. There we go. No. What? Well, okay. That did work, but not really. Because I set the date to 1/2/1989, not 2089. So there's definitely a little bit of a Y2K bug in the BIOS, or the way it interfaces with this clock utility, and probably some other clock utilities that are probably floating around. I can see this one is from 1995, probably worked fine. Either way, clock circuit on air definitely is working, even though there's no battery in here. It's able to keep the date for a few seconds when I had it off. So that's cool. Let's go to check it so we can try to see what kind of CPU speed we're getting, what kind of performance this machine has. It feels pretty slow. I'd say this is running in 4.77 megahertz mode right now. And we should be able to see if this has that COM1 port that we thought it had on board. Yes, COM1 is at 3F8, so that's the built-in serial port that's on the motherboard. Base memory being 639K, not 640, that's because XT IDE steals 1 kilobyte from the main memory. It says that this is an original HP Vectra, but the ROM BIOS is Mitsubishi branded. Did Mitsubishi actually reverse engineer a BIOS that was non-copyright infringing? I didn't know that. But it's funny that it says that it thinks this thing's an HP Vectra. This is unusually telling us that there's 48K of system ROM by Mitsubishi, which is weird because that's more than it actually has on the motherboard. So it only has 20K. So I'm wondering if there's a gap in between the two chips that are on here, possibly. All right, here's our clock speed. 7 megahertz. This feels so slow for 7 megahertz. Let's see what this compares to with a regular IBM PC. 1.23 times an IBM PC at 4.77 megahertz and at a clock speed of 7? That doesn't make sense. And you don't get a total linear scaling, but this thing must have additional wait states happening over if you ran a regular IBM PC at 7.16 megahertz. I feel it would be faster than this computer is. I guess what I need to do is go switch the switch on the back to standard speed, and let's see if it has a 1.0 multiplier versus the IBM PC. First, real quick, we'll just check this MIPS benchmark here. I kind of like this because that first column there is a multiplier versus the PC, and we'll be able to get a better idea of how much faster this thing actually is. Okay, so we're at 1.5x the performance in this particular benchmark versus Checkit. I don't know why Checkit was actually so slow. Curious. Okay, so something weird just happened. I was looking at a different window on my computer, and the computer just made a loud chirp sound. I don't know why. I didn't touch it. Oh, it's frozen. So it crashed. So maybe there are some faults with this machine. Very interesting. Control-Delete still works, though. What the heck? What I was doing when I went to crash is I was going back to the manual just to take a look and see the switches, because I wanted to see about clock speed. And it's going to be switch 6, up for 8 megahertz, or 7.1 really, a bit of a rounding thing, down for 4 megahertz. I just noticed here, you can disable the RAM checking altogether. That's cool, let's do that. Switch 5 on the up position, and we're gonna put switch 6 in the down position. All right, let's see how that does. I just turned it on. The fan is unbelievable. Whoa, yes, that's cool. It's not as fast as the super fast BIOS with Glad BIOS and the modified stuff, but that is a massive improvement. Now, of course, we're having the crashing problem, which, well, we'll need to kind of look into that. But right off the bat, we can check to see our CPU speed. We should get a 1.0. If this thing really is 100% PC compatible. No, clearly I switched something incorrectly. Yes, I put switch 6 in the down position. That's the 8088. Yes, it just crashed again, by the way. And I did set switch 6 to off, and it should be switch 8. That should be in the down position. Now, what I was going to try to do is change that switch while the system was operating. Oh, it didn't crash. What? Okay, well, let's see if it actually took effect while the machine was on. I never power cycled it when I changed switch 8. Oh, yeah, it worked. Okay, so we're getting 1.0. So this thing really is running at 100% standard PC speed. Now, it's hard to know if the timing is exact. Could you run a regular CGA card and run 8088 miles per hour or area 5150? Good question. All right, with that switch 8 set to 4.77 megahertz, even check it is exactly 1.0. So cool, it performs exactly like an original XT does. Okay, I don't know what's going on, but like I hit the period key and I hit the comma, like we're getting, it's like we're pushing shift key, which I don't get. It's not the caps lock, because now we have uppercase and now we have lowercase, but those keys are still stuck. Is this something with the shift key going on? Is it my keyboard? Okay, I just pushed the left shift key and now it's back to normal. I think this might be the keyboard. I don't think it's necessarily the computer here. So questions I have are, first of all, when we tried to run edit before, it failed. So let's see if that still happens. And then I'm wondering if we just have RAM errors on this machine. Now, edit, it does take a long time to load. That's normal. But it doesn't work. That's interesting. When check it's working fine and other things seem to work, edit does not. And that would imply that QBasic wouldn't work, because it's the same thing. Edit is just part of QBasic, really. Let's see if it's actually running. If I hit Escape, Alt FX. Okay, that's very odd. And I know for sure there's not a problem with this CGA card. This works fine. This is something with the BIOS on this computer not being fully compatible with edit. I'm going to try mode CO80. Yeah, there we go. And if we run QBasic, it's going to fail in exactly the same way, since, like I said, it's the same thing. Edit.com is like a stub loader for QBasic that just puts it into a text editor mode. Same exact thing. Just not working. So I suppose the question now with this machine is, what's that weird chirp that it does occasionally, especially after I ran that MIPS utility? And one time it did it and then it froze, but another time it didn't freeze. So is that a fault, or some kind of screensaver, or some other weird incompatibility? I'm going to switch this thing back to 8 megahertz mode, well, 7 point whatever, which you can do while the system is running. So it'd be nice if it just had a front turbo switch, wouldn't it? Okay, well, I said you could do it while the system is running, but I did just try to speed it up, and now the computer has crashed. So I guess it does not appreciate changing the clock speed while it's running. The no memory check is a very nice feature, I have to say. Very nice. Now, to potentially diagnose any potential issues with this computer, I wanted to run the XT RAM test, the March testing, and I went to go copy it onto my compact flash card. This is it right here, this G drive. And well, it wasn't letting me. And I would try to create a new folder and the whole thing would disappear and Explorer would crash on my computer. So I'm making the assumption there's something corrupted on the card. So I'm running the scanning and repair function right now. So let's let that run through. So what we can do for the XT RAM test is I can use this loadxtrt.com to actually load this test directly from MS-DOS. It takes over the whole computer. You can't exit it or anything like that. But it's a really good way to run this on a computer that's mostly working and bootable into DOS like this machine is, and then let it really run a stress test on the entire 640K of RAM. Okay, I don't know what's going on. Windows was unable to repair your drive. Close the dialog box and try again. Are you freaking kidding me? What is going on? It says the free space on this drive is 0 bytes, which is not true by any means. Okay, I stand corrected. It is true. I deleted some files and now there's space. All right, so I had a directory in the utils already called RAM test, and I've copied the load xtrt and the RAM test, which I have named incorrectly here. Let's rename that RAM test.ak. I think that's all that's necessary for this to work. And this other program is a really old RAM tester that I found a long time ago, which is not very good. And Windows 11 sure continues to impress with the fact that that CF card, I guess, was full. And instead of just saying that it was full, it couldn't do a repair and just, did stupid stuff. How totally surprising. Or actually, rather, not surprising. Okay, so our benchmarks are good. That means we are running at the full speed. Let's try loading our March testing. I think that might do it. That's normal. Don't worry about that. There we go. That freaking works. That's awesome. So the good thing about this test is it will just run indefinitely. And it's really a good stress test to see if your RAM subsystem is working properly. And that first 128K, that first column, that of course is our onboard memory on the motherboard. And then the rest of that is on that 8-bit card that's in this computer. So I'm just gonna let this sit here and run for an hour or so, which is a good stress test of the computer to make sure that, power supply and everything else is working good. And we wanna make sure that there are no errors here as well. I know I'm definitely biased about this particular RAM test, but I absolutely love this. And I just wanted to show that you can run it on a machine without even having to have flash or BIOS, which is what we're doing here. Okay, we'll be back in about an hour. All right, I'm back in. Yep, no problems. This thing is just cruising along without issues. I was upstairs, was watching a little bit of YouTube, and I realized what was causing that beepy sound. I'm quite sure the problem with the beeping is this keyboard cable on this poor Model F. It's not in great shape, and I'm pretty sure that there are some broken wires inside, and if you turn this a little bit, I think it causes a short. And I bet you this computer beeps with a keyboard error. And the reason why I couldn't type anymore was I bet you this was also not making a good connection. I do have a replacement keyboard cable for this Model F from my friend Vax11, so I really need to make that swap. He sent it to me like 2 years ago and I haven't done it yet. But what I have learned by using this computer and letting it run through that little bit of a burn-in test with the XT RAM test is that this Sperry, aka Mitsubishi, aka leading edge computer is working perfectly. So all that's really left to do at this point is screw these cards in, put it back together, hook up a monitor, and I guess play some games. Oh, and before I do that, I will dump the ROMs. I forgot to do that at this point. I will upload those to archive.org. There'll be a link in the description below. Well, there's the Sperry PC, and it's been working absolutely fine. I've been playing games for the last hour or so, 0 issues whatsoever. I think that little bit of beeping that we heard before was definitely the keyboard connection on this Model F keyboard just being flaky. You might be noticing that we're in Plantronics mode for Attack of the Petsky Robots. This is strictly because I'm using the VTech card that's in here. The Genoa card still, I don't think is gonna work. So there'll be a future video on the second channel where I try to take a look at that thing. And as for this machine itself, Mitsubishi being a massive company, especially at the time in the 80s, well, they made a really, really good quality PC. Obviously this computer completely works, it's built like a tank, and it's not just another super derivative IBM PC clone. Yeah, of course it's compatible, 100% compatible. I'm not quite sure about that because Edit doesn't work and QBasic doesn't work, but it's most of the way there compatible. And of course the BIOS, which has a 1983 date code, shows they were working on this thing pretty early on. If you know anything about the lineage of the Mitsubishi Drive BIOS, I'll be very curious to hear about that in the comment section. Is it something that was just from Phoenix or one of the other companies, or is this something that they worked on themselves? As far as the hardware itself, you saw this thing just worked perfectly. There was really nothing wrong with it at all, other than the weird quirks of the power supply needing a little bit of load on the 12-volt rail for it to actually work properly. So just keep that in mind, that if you unplug even the floppy drive, there's a good chance this computer will not actually work. I know I didn't actually show it turning on without the floppy drive connected, but we saw what was happening with the electronic load, and it definitely was not bringing up the 5-volt rail correctly without a little bit of load on the 12-volt rail. The other thing to keep in mind with these machines, if you run across one of these or the leading edge variant, is that it does have a NiCad battery. And while this one didn't leak, there's a good chance that other ones have. So if you have one of these, get this out of there immediately because you don't want it leaking and destroying the motherboard. The only other cool thing about this computer, of course, is that little bit of flare it has with the power LED that blinks when there's a post error. It doesn't seem to have a blink code. It just blinks to tell you there's an error. But if you have the speaker plugged in, you're gonna hear the beep codes. So I suppose in a way, if you unplug the speaker because you're annoyed with the noise, then you'll have at least a visual indicator that there's an issue when it doesn't post. Plus, I really like the ability to flip that dip switch on the back to bypass the memory checks. That's a nice touch. But things this thing does lack is there's no physical reset switch, there's no turbo switch, and well, it's just convoluted with all of those dip switches. The fact that it has 3 banks of dip switches seems a little bit unnecessary. Luckily, we have the manuals though to explain how the dip switches work, and that's all I had to do to get this thing working was that one dip switch. Otherwise, yep, this is a pretty cool computer, and I'm really glad to have it, and I'm really glad to have explored it on this video. So if you enjoyed this episode of PC Archeology, I'd appreciate a thumbs up. But if you didn't, you know exactly what to do. Huge thanks to my supporters, names are going beside the screen. They make it possible I do this full time. And you know all the other usual YouTube junk, subscribe and comment and all that stuff. And that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.